Okay, so here's my final try for number 10, the last question. And again, I think we're looking at alternate series here, alternating series, again because of this little guy here. And so I think that in terms of the two conditions with this one, the first condition is that the limit as n approaches infinity of that whole thing has to equal 0. And I think we can see that that must be the case because all of these values will keep increasing as n approaches infinity. Just looking at the ln of ln n. If we have ln n equal to, if ln n with n equal to infinity, that would be infinity, and then we would take ln of infinity, and again that would be infinity, yeah. So it's going to definitely, this one is going to go to 0 for the limit. So we've got the first condition met. The second condition is that this series has to be decreasing. And so if you want to try a few values, starting at 3, don't forget, for n equals 3, then I think you'll find that the denominator is growing and growing and growing. And what happens is the first denominator that you get when n is 3 is actually something like 1 over 0.3 something something something. That's actually going to be 3 for the first term. And then it jumps and it goes to, I think, 2.36, 1.81. And so then we're dividing 1 by a number greater than 1. And then if we keep going, this number is going to get bigger and bigger. And so that means that each term is going to be decreasing from there on in. And so that condition seems to be met. Now, I see in your last email that you said that if you decide that it's convergent, and this one definitely looks like it's convergent, then you also have to state whether it's absolutely or conditionally divergent. So my understanding of that part of it with the absolute convergence or the conditional convergence is that if we now go back and we look at this series and we take the absolute value of it, we see whether or not it would actually give us a convergent or a divergent series. So if we take the absolute value of minus 1 to the n plus 1 times this whole mess of a denominator here, okay, then all of your terms are going to be positive. And we've kind of started up here with the first few terms, and you can see that it looks very much like the harmonic series where it's going to be adding on another term, another term, another term, another term, and it's going to diverge. And so the absolute value of this series diverges. It's only because of the minus 1 to the n plus 1 up here that this series converges, because it's an alternating series. And so in that case, we say, therefore, that this series converges conditionally. Now, I didn't see that before before I did your first video, but the reasoning would be the same there as well. With the 1 over root n, other than that one, having that -1 to the n plus 1 to make it an alternating series, that one's going to converge conditionally also, because it's going to keep adding and adding and adding and adding, and it's never going to converge. So the alternating series converges, but the absolute value of that series diverges, and so we say that that one converges conditionally also, and that was number 9, wasn't it? Number 8, I'm still not sure of, just because of the sine function that's in that one. Sorry, I'm drawing a blank on that one, and I'm not sure exactly what to do in terms of deciding on the convergence of that one. It's that second part of it where it has to be decreasing, and I don't think it meets that criteria, and so in that case, I think we have to conclude for number 8, for the question with the sign in it, that it's divergent. And that's all I have on that one. I'm sorry. So I hope that the other ones are helpful. I think that they're a little bit more solid in terms of the explanations. At least I think we know that we're on the right track with 9 and 10 at least.